In this next section, we revisit an idea that a lot of math teachers call foiling. Some teachers use the box method. That's probably a thing you've heard before. And I'm going to show you both. I'm more of a foiling kind of person myself. I don't generally do the box method very much. But whatever, let's do it. I will do the box method on one or two of them. M times M. Basically, I'm going to distribute, sorry, got out of focus there. I'm going to distribute this M, this first one, to everything over here. So M times M and M times 6. Let's just do that first. So you know over here we were like 7x times this and 7x times this and 7x times that. Well, now it's M times this and M times that. And again, I want to point out that we are multiplying because there's no plus or minus in here or division or anything else. It's just two parentheses crammed together, which means they're being multiplied. So M times M is M squared. M times 6 is 6M. It is positive. Let's put that in there. And now we'll distribute these. 4 times M is 4M. 4 times 6 is 24. Now, I don't know if you realize it or not, but you just foiled, meaning you did this. You multiplied, let me switch colors for no reason at all. You multiplied first, outer, inner, and then last. Some teachers don't teach it that way, and some do. But basically, you did the first two, the outer two, the inner two, and then the last two. And that's the thing, and you can do it. That process doesn't work here. Technically, you're not foiling down here. But you are distributing. And so then at this point, I'll look at these and I say, oh, well, I have, let's see, M squared. Those two are alike, so 10M, and then 24. There you go. And we're done. Now, eventually, we're going to start going backwards from here back up to there, and you've done that before. But for now, we're not. So here goes. Let's distribute 3x times 2x, 3x times negative 5. And we're back in focus. 3x times 2x is 6x squared. 3x times negative 5, well, 3 times negative 5 is negative 15, and then x. 2 and 2 multiplied gives me 4x. 2 times 2x is 4x. 2 times negative 5 is negative 10. We'll put those two together, and we have 6x squared minus 11x minus 10. Okay, let me pause this right here and just kind of tell you what some teachers teach, and you've probably seen this box method before too. So here goes. 3x minus 2, and then 2x minus 5, and they make a little box, and they're like, hey, let's just multiply stuff, and it works. It's great. It's a great way to organize your thinking. 2x times 3x is 6x squared. 2x times negative 2 is negative 4x. 3x times negative 5 is negative 15x, and those two multiply together give me 10. And then these two together, whoops, that's a positive 2. So that would be a negative 10. Whoops, sorry, messed up right there. And that's positive 4. When we put these two together, negative 15 plus 4 is going to give me that negative 11x I wanted in the middle, right? And I've got my negative 10. I got my 6x squared. I've got everything. It's all there. It's just a different way of organizing it. So I might resort to that when I get to one of the more complicated ones at the bottom, but I might not. We'll see how the mood hits me when I get there. Let's go to the next one. Let me tell you what not to do on the next one. I have students in all levels of classes that will do the wrong thing, and they'll say, don't you do this. Please don't write this down. It's wrong. They're going to say, I'm going to square you, and I'm going to square you, and they're going to be like 2x squared, and then negative 1 squared is 1, and they're done. That's wrong on so many levels. First of all, you have to square the whole thing. Second of all, just write it twice, and then foil it out or distribute or box or call it what you will. But basically, if I'm squaring something, I'm multiplying this times itself. So I'm doing that. I have two of them, and now the whole process changes, it looks like, because I'll go 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. And then I start distributing the other one. Negative 1 times 2x is negative 2x. Negative 1 times negative 1 is positive 1. I'll look at those two and I say, wow, these two terms sure are alike. So then the next step, the final answer, is 4x squared minus 4x plus 1. Okay, I want to show you this one because it's a little different. And it's not different in the process, but it's different in the final answer. You're going to encounter this when you're factoring. X times x is going to give me x squared. X times 8 is going to give me 8x. No surprises there. Positive 8x. All right. Negative 8 times x is negative 8x, and negative 8 times 8 is negative 64. And then these two go together. And when they go together, they cancel each other out. I have 8x minus 8x. So 8 minus 8, well, they cancel each other out, so they're gone. And so I have x squared, 0x, don't even write it, minus 64. So notice I don't have a middle term here other than the understood 0x. Okay, when I get to this next one, we're going to have a big mess. You can use the box method with this, and I will on the next one, but right now I'm not. So let's go by doing this, and oh my goodness, there's another term. So because I'm going to run out of room vertically, I'm going to just bring it over here. So t times 3t squared, that's 3t cubed. T times negative 4t is negative 4t squared. T times 2 is 2t. Yay. 2 times 3t squared is 6t squared. 2 times negative 4t is negative 8t. 2 times 2 is 4. Okay. We're going to put our like terms together. I will jump straight to the final answer. I'm looking for things that are cubed. The degree of this is 3. That one's cubed. He's the only one that's cubed. And then I say, oh, these two are squared. All right. Negative 4 plus 6. That would be 2. And then 2 minus 8 would be negative 6. And then 4. That's the only one of his kind. He's the only one that's just a number with no variable. And so that it takes a little more simplifying, but it works. So same thing on this next one, and even the one after that. The one after that's going to be big and sloppy. But if you wanted to, you could use the box method. Do you want me to use the box method on this? Why, sure, Mr. Reader, go ahead. All right, cool, I will. 2y squared and 5. Now, if you want to be like, oh, I don't like the box method, it's confusing, then just distribute. You're cool. You want my opinion, I'm not a big fan of the box method myself. I'd rather just distribute. But whatever. Negative 3y. Positive 4. Now, on the box method on this one, we might run into some problems. Not everything's going to line up all nice and neat and pretty and have like terms just beautifully everywhere. It may not. This one's a little sloppy. It's okay. You switch colors inside just to show that it's different. This times this. So 2y squared times y squared is 2y to the 4th. 2y squared times that, negative 6y cubed. 2y squared times 4 is 8y squared. Okay, fantastic. 5 times y squared is 5y squared. This one's not going to line up like you think it does. 5 times negative 3y is negative 15y. 5 times 4 is 20. Let's write this down. However, often when you're doing the box method, you'll circle these and you'll say, oh, these diagonals, they're the same. They're like terms. These are not. See, notice that's y squared, that's y cubed. That's y to the 2nd. So we don't have like terms diagonally like we have had. So this one's going to take a little bit of writing. So 2y to the 4th. By the way, if you didn't do the box method and you were like this and this and this and this and this and this, you'll get the same thing I'm about to write. 2y to the 4th minus 6y cubed plus 8y squared plus 5y squared minus 15y plus 20. There's all 6 terms. By the way, let me point out something. 2 things here times 3 things here. Well, 2 times 3 is going to give me 6 terms. Now, in a minute, these two will go together. They're the only 2 that go together, but it does get simplified. So 2y to the fourth minus 6y cubed, and then 8 plus 5 is going to give me 13. There we go. We have simplified it. We have 5 terms in this one. This is a 5-term polynomial. What would that be called? A quintinomial? Anyway, for this next one, if you do the box method, you're going to have a big old box. I choose not to. It's going to be sloppy, though. I'm going to go ahead and warn you. Here goes. 2x squared times x squared. 2x squared times 5x. 2x squared times negative 2. I'm going to write all those things down. So 2x squared times x squared. That would give me 2x to the fourth. Let's put equal signs here. Multiply those, you get 10x to the third. Multiply those, you get negative 4x squared. Okay? We good so far? Boy, I hope so, because it's about to get nasty. Negative 3 times this. Negative 3 times this. Negative 3 times this. Negative 3x squared. Negative, oh, cubed, sorry, negative 3x cubed. Multiplying those two. Multiplying those two. Negative 3x times 5x is negative 15x squared. Negative 3x times negative 2 is positive 6x. All right, now we're going to distribute this. 4 times that, 4 times that, 4 times that. So 4x squared. 20x. Negative 8. Oh my word, we've multiplied 3 things times 3 things, so we have 9 terms here. Let me glance through the work very quickly and make sure nothing is wrong, because I'd hate to proceed with something being drastically wrong or even partially wrong. Those are good, and those are good. Okay, so now we're going to put our like terms together. I'm looking for other things that are to the 4th power. Nothing else, just him. Okay, so looking for things that are to the 3rd power. There's one, there's another one. So 10 minus 3, 10x cubed minus 3x cubed is going to give me 7x cubed. All right, things that are to the 2nd power, and we'll switch colors just for fun. And we'll underline it squiggly. These are squared. Negative 4 minus 15, that's negative 19. Negative 19 plus 4, we're back to negative 15. See, these two cancel each other out. Negative 4 plus 4, so we have negative 15. Negative 15x squared. Okay. I'm looking for my x's. Here's 1. Here's 1. 6 plus 20. I do believe that would be 26. And then, last little guy over here, negative 8. There we go. That's the biggest one you'd ever see that you're multiplying together. It's a mess, isn't it?